Hi, I'm going to take you through how we can trace algorithms in this video. This comes up in both paper 1 and paper 2. An algorithm itself is just a set of instructions that can solve a problem when they are followed. We have them everywhere in computer science, and the main way in the exam board will express these algorithms is via pseudocode. So they won't ever show you Python code or Java code, they show you pseudocode. And pseudocode is a made-up programming language. It's meant to resemble real program code, but it doesn't have a set syntax. And every human being on Earth could come up with a slightly different pseudocode if they were asked to write some pseudocode for a problem. But it's meant to resemble program code. So to give you a few examples, I searched up the binary search algorithm and tried to look at a few different websites. And each of these websites have chosen to show the binary search algorithm in pseudocode. The benefit of showing it in this made-up language is that any programmer should be able to look at these algorithms and understand how they work. If you are only ever showing it in Java or C++, that's going to alienate a Python programmer and vice versa. So pseudocode in real life is meant to be this happy medium which all of us can understand. That being said, there is a slight complication with this particular course because OCR have produced their own version of pseudocode and some syntax to go alongside this. Now that's probably a good thing. It means we've got this consistent use of pseudocode, which you can learn. This is called ERL at GCSE, so you might still call it that or hear that being used. And crucially, you must be able to understand and follow OCR's pseudocode. So in this playlist, I'm going to show you all the different constructs you've got to know about in OCR pseudocode, although you probably will also know this in your programming language. You're able to answer any written questions in the language you've studied, but you need to be able to understand and follow their pseudocode because that's what exam questions will be written in. And all of this is pertinent to tracing algorithms because ultimately they're going to show you some code. This code will not be in Python, it will not be in Java or C++ or whatever you've learned. This will be in pseudocode. And tracing algorithms involves you going through the code line by line as if you were running it yourself. And that means you've got to understand how their code works to be able to do this. Now, questions won't always say trace through it. They often kind of imply this with a question like, well, given this function definition, state the output from this function call. And they'll be expecting you to go through their code line by line and try and figure out what it's doing and then figure out what the end outcome is from it. Now, if you don't really understand how their pseudocode works, skip this video and come back to it later once you've watched my videos on the underlying concepts. However, if you do know how this works, let's have a look at some of these example tracing questions. So to do this actual question here, we've got the argument 2445. It's very tempting just to kind of look at it and try and guess what the answer is. That's not the point. When we're tracing, we're going through it line by line, almost as if we were the computer. So number is being set to 2445 in this function call. We are then setting temp to be equal to the string version of this. It was an integer, but now we're making it a string. Max is set to be the length of temp minus 1, which is going to be 3. And we'd advocate, like I'm doing here, just sort of like annotating my code as you go, so you keep track. Total set to 0. And we've got a for loop for x is equal to 0 initially. And we're going to keep going until we equal 3, because that's what max was. This means this loop's going to repeat 4 times. And then this digit line is a little bit confusing. We are starting with our kind of inner brackets first. We are finding a substring within temp, which starts at index x, which is initially going to be index 0. And then in substring, the comma and the second number refers to how many characters we want. So all that's saying is, I want 1 character at that index. So all we're getting there in that first run is 2, because 2 is at index 0. And we're then making all of this, which is effectively 2, we're then making it an integer again, because it was currently a string at that point. And then we are multiplying digit by itself, so squaring 2, which is 4, and we're adding that to the total. So total is now going to be set to 4. So you might want to keep track of it being equal to 4 there. We go back around. X is now equal to 1. So we're finding index 1. We are making it an integer. So we're now looking at 4 being digit. 4 times 4 is 16. So we're adding 16 to total. 4 plus 16 is 20. X is now equal to 2. So index 2 is another 4. So we're doing another 4 squared, which is 16. We're adding that to the total. 20 plus 16 is going to be 36. X is now equal to 3. We are going to still loop because in OCR pseudocode, it's an inclusive for loop, as we'll look at in that video. We are finding 5 out of that location. We are squaring 5. 5 squared is 25. So we're adding 25 to this total. 36 plus 25 is about 61. We don't loop again because we've reached our maximum limit of our X counter. So at this point, we return total. Therefore, the answer is 61. So what are the key takeaways from doing that question? Well, first of all, when you're tracing through an algorithm, you've got to go line by line. You've got to play dumb and not try and predict what's happening. You might understand the pattern quite quickly, but still go through it until it completes because there might be a trick which you haven't seen. And secondly, you've got to understand how OCR pseudocode works because there are things in this algorithm you may not understand unless you learnt it, like what does substring do? And also the fact that it's an inclusive for loop. If you didn't know that because you've only ever learnt Python or Java, well, you're going to get that wrong. Sometimes you can be asked to trace through stuff a little bit more directly via a trace table where you're given some code and then you're given a table this time to go through it. And the columns in a trace table can represent pretty much anything that could change in a program. Normally the trace table will be completed for you. If it's not completed, you can just put in all of the variables being used, perhaps some conditions. So this middle column here with mod in it is part of my condition. So I might put this in so I can see what it's doing. And then output represents anything printed to the user. Now it's tempting when you're given a big table to just try and fill in every box. You don't have to. Trace tables often look a little bit empty, even when they're complete, because we only write down into each box whenever a value changes. So it's easier for me to show you that than explain it. We start with x, which is a variable, being set to -1. Well, we need to mark that in my trace table. The second line, we're setting an array called data to be equal to these values, but that's got no reference at all in my trace table. Therefore, I don't ignore it because I'm still reading the line, but I don't have to write anything down because it doesn't affect anything in my trace table. We then have got a for loop here where we've got I being set to 0 initially. So I can put down a 0. Now, where you put down the 0 really depends on what type of trace table it is. This one here hasn't got any line numbers in it. Therefore, it's a little bit up to you where you place it. I mean, you're either going to place it here or you're going to place it here. You wouldn't place it down there because that doesn't make much sense. We're meant to be showing this sequentially as it goes through. These top two choices would be really up to you. Personally, I would put the 0 in that second line. And that's not because it's on a different line. It's because in my head, this is a different section of my program. I've got a bit of sequence at the top. I've now got a bit of iteration. So I'm going to try and put all of my iteration code within the same block. But you wouldn't get marked on the exact position. It's about the order of these values in your trace table. So anyway, we're going to start with I being 0. We're going to keep going till we equal data.length -1, which is going to be the length of that is 5, -1 is 4. So we're going to keep going this time until I is equal to 4. Again, that's not in my trace table, so I don't need to pay much attention to that apart from just checking, understand what it's doing. We've then got an if statement where my middle column is being used. So worth us filling in this middle column now. Data index 0 mod 2. What is that going to be? Well, data index 0 is 5. 5 mod 2 is going to be 1. Again, I could put that 1 either next to it or below. Personally, I'm going to put it next to it because I tend to think of this being the same block of code, even though I do understand there is some selection going on. So personal choice, you could put 1 below if you wanted to. You wouldn't lose any marks either way. So if I look at my code, that, which is now 1, if data index 0 mod 2 is equal to 0, 1 is not equal to 0. Therefore, we don't run any of this code. We instead go back around to my next for loop. So I is now going to be equal to 1 as we go through these indices. We do data index 1 mod 2 again, this time looking at 2. Well, 2 mod 2 is going to be 0. Therefore, this if statement does run. We therefore look inside. If data index I, so if data index 1, which is 2, is bigger than x, we're going to set x to be that value. Well, 2 is bigger than -1, so therefore we are going to set x to be equal to 2. Again, you could do that below. Again, I'm thinking this as being one block of code, therefore I'm keeping it on one line, but that's really your call. So that bit of code there is essentially going, if our item at that location is bigger than X, set X to be equal to that item. At that point, we need to loop again, and now I is going to be set to 2. If data index 2, which is 6, mod 2 is equal to 0, well, 6 mod 2 is equal to 0. Then we're going to run this code. Is 6 bigger than X? Yeah, 6 is bigger than 2. Therefore, X is going to be set to 6. Now, we go back around. I is equal to 3. Data index 3, which is 9. 9 mod 2 is 1. Therefore, I don't run any of the code inside that if statement. I is now set to be 4. We keep going because, like I said before, these are inclusive in OCR pseudocode. Index 4 has the item 3 in it. 3 mod 2 is also 1. So again, none of the code inside is going to run. I doesn't become 5 because we've hit our limit. Therefore, we simply exit this for loop, print X, which is going to be 6. That was the last value of X. You put the 6 either here, or I think it makes more sense to put it at the bottom there because again, we've kind of exited this iteration block back into a different part of our program. So I think that looks a little bit better. But we can see here, essentially the end value was 6, X ended up being 6. Now trace tables are a little bit of a pain. The purpose is to, first of all, understand how code works. They often ask you as a follow-up, well, what does this code do? And this code here, if you want to know, or maybe you're thinking about it, this finds the biggest even number in the array. We also use trace tables to find tricky logic errors, which might be hard to detect otherwise. This code here doesn't have a logic error, but equally, there might be one, and that's why it's important that you don't guess at what it's doing. You are going through slowly, methodically, one line at a time. Let's end with one more example. Practice definitely makes perfect with trace tables, so worth you pausing and trying this beforehand. This is a different style of trace table because we have line numbers being used here, which is done from time to time. We've also got array elements in this trace table as well, which is perfectly fine. They often do start it off for you. So you can see line 1 has been completed already by putting each element under the index of this array. But line 2 hasn't been done yet. So line 2, we're setting start to be equal to 0. Line 3, we're setting end to be equal to the length of nums, which is 4 minus 1. Therefore, end is set to be 3. Now, line 4 is empty. We wouldn't write down line 4 here. You wouldn't lose a mark if you did, but it's just pointless because we only write down stuff in a trace table when something changes. Likewise, line 5 isn't pointless because we've got a while loop, but this while loop isn't reflected in my trace table. So I need to read that line still, but I don't need to write anything down. However, because start is less than end, we are going to run line 6, and stuff does happen here because temp is set to be nums index 0. Well, nums index 0 is 3. The temp is set to be 3. At line 7, we are reassigning nums index 0 to now be equal to nums index end. Well, that is nums index 3. So the start, which is the item 3, is now being set to what the end item is, which was 9. A little bit confusing, but we're reassigning the first item to be the last item, essentially. And then in line 8, we're setting nums index 3, which was 9, to now be equal to temp, which is 3. Thankfully, line 9 is a little bit simpler. We're simply adding 1 to start. So 1 plus 0 is 1. And in line 10, we're subtracting 1 from end. So therefore, that is now equal to 2. Nothing of note happens at line 11. That's just us ending while loop. We go back up to line 5. Is start still less than end? Yeah, 1 is still less than 2. Therefore, we're not done yet. We've still got to keep going. We're back at line 6. Temp is set to be nums index 1, which is what start currently is. So what is nums index 1? That is 2. So temp is now going to be set to 2. In line 7, nums index 1 is now going to be set to nums index 2. So what was 2 is now going to become 4. At line 8, nums index 2, which was 4, is now going to become what temp is, which is 2. And then at line 9, we are adding 1 to start. We are then at line 10, subtracting 1 from end, like that. And now we go back around to check our while loop condition. Well, now start is no longer smaller than end. So therefore, the while loop doesn't run anymore. We skip this now, we're done with it. We go to line 12, nothing happens. We go to line 13, it prints nums. However, I've not got an output column in my trace table here, so therefore there's nothing to write down. But if there was a follow-up question asking what this code is doing, we might want to see what line 13 is doing. What is nums going to be at this point? Well, it's going to be index 0, the last value was 9. Index 1, the last value was 4. Index 2, 2 was the last value it was. And then index 3, this was 3. Well, what has this code done? As you may have spotted, this is reversing this array. So it's swapping down around the order, so it's now the other way around, which you might have been able to tell just by staring at the code. However, doing the trace table does make it perhaps a little bit easier to understand what's going on because you've actually tried the code yourself. So go slowly, don't rush these, they are worth quite a lot of marks. And don't worry if you see gaps in your trace table afterwards, that's very normal and is expected.